Hello, everyone. Thank you for being here. Thank you for the organization to invite me. And let's start. My name is Carlos Mota. You can find me on Twitter on @CFonsMota. I usually tweet a lot about programming stuff, namely on Kotlin, so feel free to follow me. Who am I? I'm an Android developer for the past 7-8 years. I also been on the dark side on iOS for a whole year. And basically, for the past year, I've been playing with Kotlin Multiplatform, and we'll be on it in a few seconds. You can find this presentation. It has some code. You don't need to take pictures. You can find it on a speaker deck. And before we start, just for me to have a notion, who's an Android developer? Let's put your... Okay. iOS developers? Tough luck, man. Web? Okay. Server side? Okay, nice. Don't worry, because on Kotlin Multiplatform, you can use Kotlin for all of these platforms, okay? This is the cool thing about Kotlin nowadays. So, a brief history of time. Well, this is a problem on mobile. You have two major players. You have got Android and iOS. Oh, wait. Now I fixed it. Okay. You have two bigger players. Biggest feature of 2019. And let's see this example. I want to build an application. I had a wild idea, and I want to do it for Android, and I want to do it for iOS. So I need to hire a team for Android and iOS developers. Okay, I need to hire at least 2 people. I need to define the requirements. I need to plan how to develop these features. I need to start the development. I need to write unit tests. I need to write T-specs for the Q&A to validate. And then I have to cross-check if every feature is implementing the same way on Android and iOS. So in the end, this means that I have double the time and the resources required to develop an idea. And we can even add web to this. And if we add it, we basically have 3 times more. 3 times more the cost for the company, 3 times more the time spent. And I hope everyone has seen this movie and what this means. We want to split the cost in half. And this is a big game for Kotlin Multiplatform and for a lot of frameworks that exist nowadays. So let's try to find a solution that works on all platforms. And we've been doing this for the past 10 years, okay? We started before App Store was launched for Symbian OS, for Palm OS. We had PhoneGap that still exists today. We had Xamarin, we have React Native, we have Ionic, and nowadays we even have Flutter, okay? And these solutions are really good, okay? But we have one even better. Why is this good? Okay, the big advantage here is you can hire only a team that knows how to develop, for instance, for the web, and you can do this for native. Or you can hire a Flutter team, that's a big thing nowadays, and you can do it to develop both for Android and for iOS. And this is particularly good because the learning curve, when you're doing it for mobile, if you're a web developer, you can do this fairly easy. Of course, this also has a lot of problems. The biggest problem here is all the UI, all the views, are strictly linked to the framework. So let's see. There is a new iOS release, and Apple decided to redraw the entire component, okay? When you run your application with that framework, you will still have the old look, because people from that framework need to implement new components. And this is the biggest problem nowadays. Of course, you also have an argument here that, for instance, Flutter uses Dart. Dart exists for some time now, but it doesn't have a big community. It's starting to grow, but it's still small if you compare it to other languages. So how can we have the best of both worlds? Kotlin. Easy, I know. So what's Kotlin?
Tyle ketchupu Kotlin zmieści się na frytce. Tyle na kanapce. Tyle na burgerku, a tyle na żeberkach. O, a na szaszłyczku jeszcze więcej. Nie ma konserwantów, nie ma ograniczeń. Jesz tyle, ile się zmieści. Kotlin, I love ketchup.
Yes, it's Ketchup. And for quite some time, when the people from JetBrains searched on Twitter for Kotlin, this was what they were getting. But we've passed this, and nowadays Kotlin is used for Android developer. In 2017, Google said that it will support fully Kotlin for Android. And the good thing in this year, during Google I/O, they say that everything that is shipped for the Android platform is 100% Kotlin. So, okay, we can assume Kotlin it's 100% mobile for Android, okay? The big thing here, it's just not anymore for Android only. We have Kotlin JS that works pretty well. We also have it on server side. We start to have some companies developing it in Portugal on the back end. We also have it natively. Another good thing about this language, it's the amount of language features that we've got available. Okay, Java was stuck in time, is stuck in time, and especially on Android, for instance, Java 8 was launched 4 years ago or 5 years ago, and up on last year, we only have a small feature set of Java 8 on Android. 2 years ago, we had a small subset of Java 8 features on Android. Nowadays, we have all the features that Java 8 already supported with Kotlin, and we have much more features available. For instance, we have null safety. Do you know that 80% of an application, I can start this another way. Who had already had a null pointer exception? Raise your hands. Come on, don't be shy. Come on, I'm seeing some. 80% of the issues that we usually have on a platform are null pointer exceptions. So a language that doesn't allow to have null pointer exceptions, it's an excellent language. And this happens, I'm not going to say 100% because when there's a will, there is a way, but 99% of the times you don't have null pointer exceptions. We have a project on production for the past 2 years using Kotlin, and they can say that we only had one null pointer exception, and that's because we did something that we shouldn't done. Another cool thing here is we have type inference, we have mutability, we have collections, we have default values. We don't need to have a lot of constructors with different values for the constructor. We can use default values, meaning that if I call a method and I only send one parameter and it expects 2, the second one will use a default value. So less code that I need to write. I'm really good at doing memes, okay? Let's see a typical example. I want to create a Porto. I have a class here that has a name, it has a local, and it has a set of text available. And this is the code in Java. 75 lines of code, because I need to write an equals and hash code to string, and they have got this in Kotlin. Yeah, that's it. 1 line. I put it in 3 just to show that it's easier to read, but you can do this on a single line, and it's the same thing. So if you have less bugs, you can focus on what really matters, to develop features, to don't have bugs. And if you don't have bugs, your boss will be happier with you, as it should. Another cool thing on Kotlin is the language features that the platform already offers you. A good type of this is collections. Let's see this example. I have a list, 1, null, 2, null, 3, 4, 5, 7, 8. If I print this, I've got this. Let's assume that I don't want to have null objects. On Java, another language, we need to do things like, okay, I want all elements that are not null to do this. We need to write a for cycle and try to see if the number is null or not. On Kotlin, I can just call this. Now let's assume that I want the even numbers. I can just call this with the expression that I want. Now let's say that I want the numbers to be from the other way around. So I can just call sort descending, and I will have the list as easy as this. This saves a lot of time, trust me. So there is a really small learning curve here. And this is especially important if you're an iOS developer, so this is for you. If you're doing things with Swift, when you try to go to Kotlin, this is fairly easy because the languages themselves are pretty similar. So the only difference here, and I've got a variable that I'm going to say that is 42, and I've got a val. A val means value. It's an immutable object that I cannot never change. On iOS, this is let. This is the only difference between both. If I go further and try to create a method, on Java I would have something like public string greet. On Kotlin I have a function, or fun, because we have fun, right? I know, this is an easy joke. And we put the type on the end. It's a type of string, okay? On iOS, on Swift, we've got the same thing. Instead of fun, it's func. And instead of having double points, we've got an arrow. Another good thing here, it's string interpolation. So it's really boring, have to print all the variables. We need to open quotation marks, write the text, close the quotation marks, open, add a plus sign, add a variable, open, add a plus sign, add the quotation marks once again. On Kotlin, we've got string interpolation, and we can just do this. Cool, right? And we now are on Kotlin Multiplatform. So what does this mean? Multiplatform, it's really, really cool because you can target a lot of platforms with a single model. So we call it multiplatform when we have more than one platform, right? So why should we use Kotlin Multiplatform? First, the approach is really different for other cross-platform frameworks there is. The language features of Kotlin are way above the others. It has low risk, okay? But you can decide as a developer what you want to share with other applications. So you don't have to share the entire thing. You should start small, and then as the time evolves and you start to know how to do things and get more experience, you can add more models to this shared component. And I'm going to talk a bit about it in a minute. It's also interoperable, so you will have code written in Swift and you have a model on Kotlin, or you have JS and you have Kotlin, and it has a really strong community support. And this is particularly important nowadays because, well, we're targeting 3, 4, 5 platforms. You will have bugs, trust me. I can tell you that I spent 3 days, 3 nights, trying to have this working with JavaScript. And I noticed that I had an issue over there because I wasn't able to compile my mobile code with JavaScript. And I went to the Kotlin Slack and I was asking, why the hell does this not work? And I had people from JetBrains that were talking to me, trying to understand the problem. Okay? And this is really helpful when you're using a new technology. Because you don't want to be stuck on something and realize in the end that you're just losing time or wasting time. So this is our first reaction to Kotlin. Come on, it's cool. We'll see in a bit. So let's assume that you want to develop an application, okay? Mobile, web, wherever. So you typically will have the presentation layer, especially if you're following some clean arc model. You'll have the presentation layer. We'll also have your model. You're going to have the parser, the network request if you make network requests, and you're also going to have your view. And you have the exactly same thing on all platforms. And you're going to have similar code written in a lot of platforms, okay? So why should you waste time to read again and again the same code just for a different platform? And this is the goal on Kotlin. You want to create a shared model that can be used in all platforms instead of rewriting the same thing over and over again. And this is the big difference when you talk about other platforms out there, on other cross-platforms. We don't care about the UI. The UI can be done natively, and we can expect the best speed possible, the best responsiveness. But we want to share the logic. But how can we interact with the platform itself if we have Kotlin written in Kotlin? Okay? Let's assume that we have an application written on Android, and I want to have the name of that platform. So we can do things like this. We can declare expect on our platform independent model, and we'll define the word actual to define what it means. There are people that say that this is like an interface, it's similar, but it's way better because you can define constructors here, and this is not possible on interfaces. But I'm going to show you an example. Let's see this example that I want to have a name, okay? If I'm on Android, I want to have the word Android, on iOS, on the web I want to have JavaScript, for instance. So on my shared model, the only thing that I'm going to do is to write expect, okay? I expect that someone will implement this thing, okay? Someone from the platform dependent code will write actual code for this. So on Android, I'm going to say actual val will be Android. On iOS, I'm going to write iOS. If you check on the top layers, I've got the source, meaning that I'm source Android main, meaning that I'm on the Android code, and iOS, I'm on iOS code. Another good thing here, it's the IDE itself. Okay, this can be done on IntelliJ. I recommend you to use IntelliJ. And when you declare an expect function and you have several platforms to target, it will automatically say, okay, you have to define the actual on all platforms. And if you double click on if you press Alt Enter, it will automatically create these classes. You only need to write the code. So basically, this is a nice diagram of what this represents. We have a common model that can be used across different applications. For instance, applications that use JVM will have a jar file that will automatically be inserted on your application. On iOS, you will have a framework object. On the web, you will have Kotlin.js. And another good thing here is that you can use your reactive components with this. So we're not strict to what we're going to use. You can still mix different frameworks. Only the shared model is done on Kotlin. The big problem here is that Kotlin Multiplatform was launched with version 1.2. This means that probably 1.5 years ago. It's still experimental. We still have some problems. And the biggest problem here is when you try to set up the project. Because you deal with a lot of dependencies, and this is really difficult. I've written a small blog post on how you can easily create your project, because it's not just new projects and select Android and iOS. You still have to do a couple of things to have everything work. And this is the worst part here. So if you want, go on, I have an article written about this. So let's try to make a demo. I've created an application for the commit. It's a really simple application that accesses the internet and downloads the list of speakers available. This is just to show you I can have the entire project on IntelliJ. I don't need Android Studio for this. I can have only my IDE. And depending on the class that the project folder that I'm at, I can have all different implementations. In this case here, I'm running on Android emulator. And then I have to switch to Xcode or app code, and then compile my code for iOS. This is the Swift code. It's fairly easy. And I only implemented the UI. All the logic from having to make a request to parsing it was done automatically by my shared model. So let's see this example. I want to implement the UI. I want to make a request. In this case, I made to a GIS on my GitHub that has a JSON with all the speakers that are here at commit. I need to parse it, and I have my own object. And then when this information is available, I need to notify the UI. And the UI itself needs to reload to have these objects on a list. So basically, this is boring components from mobile, but you'll have retrofit on Android. On iOS, it's called Alamo Fire. You have JSON. It depends, okay? In the end, they're basically the same functionalities. So the only thing that is different here, it's the UI view controller and the activity itself and the recycler view and the UI table view, okay? This is the big difference. It's how you're going to draw your UI. So just let's split them and only care about activity and UI view controller at UI level. The rest we'll deal with a shared model. And now this is the best part because you have code and we love this part, okay? It's just to show you how easy it is to do this. So, this is code written on Kotlin, okay? It's fairly easy. What I've done here is I have an HTTP client that is going to make this request. It's easy. I can just call client.get HTTP response. I need to define which HTTP client I'm going to use. So on Android, we probably will use OKHTTP, and on iOS, we are going to use iOS.create. That is available on Locator. And when after making this request, we can parse it. And when we're going to parse this, we just need to say that we're going to use a JSON feature, meaning that this text is on JSON. And we are going to use Kotlin's serializer for this. And we're going to make the parse, okay? Parse, probably a lot of people already implemented it. You need to care about the first tag, the last tag, all the tags in between, or you can just go an extra line here, and we've got this on mobile. That is, we have a JSON response here, and we can see that the keys are highlighted in bold. We have speaker, we have company, we have title, we have bio, and we can just create an object with this. If we define it as serializable, the parsing will be done automatically because it will look at these fields and it will automatically look at them on the response. So if you look at this is pretty easy to do. And we are going to do this for all platforms. If by some reason we want to have a different name, we can just say that talk_descriptions for the compiler to look instead at this tag instead of looking to the ID or to the field description. Now comes the most tricky part. We are at presentation and we want to have the presentation, our presentation layer shared across different platforms. So what you're going to define here, it's a method called attachView. So this means that the view will become visible and I want to make a request fetch speakers when this method is called. And this is going to be called from the UI. So what you do here is we want to define an interface because we were going to make a request and this request is asynchronous, so we need to notify the UI that the information is available and it can be successful or not. So we define a simple interface, in this case on new list failed if I don't have internet, if it wasn't possible to parse my response, etc. Also, this attachView method, as I was saying, it will be called by the UI level. When this fetch speaker list will be called, I can use coroutines. Coroutines is a really cool thing that we now have on Kotlin, and we can take part of it doing web, doing iOS, without any problems with it. We just need to declare how they're going to be called. How do we go, for instance, for the UI thread. And this is when we receive a response from the server, this is the method that we are going to call. On success will be called on speakers list fetched, and on failure that the list failed. This is simply the method saying that I'm going to call that initial API that I've defined, that get and that parse response. I'm going to call fetch speakers. When I have this information, I want to update the UI, so this information will run on a UI scope, and if it was possible to parse, I'm going to call on success that will call again on speaker list available. So what do you think about this? Right? Cool. So let's look at our UI code. This is standard Android code. Okay, when the activity becomes visible, we call onCreate method. It's called automatically by the system, and we want to call that attachView that we've created before, so the request to the network can be made. And when we receive that response, that will be called on new list, I want to update the UI. The only thing that I've done here was to create a service locator and then to call the attachView. And what this service locator means. Okay, this service locator will define my HTTP client, okay, and we can see this, that I'm going to use on Android the HTTP client, the only thing that I've done to run natively. As you can see, before I had an expect, and here I have the actual. So I want to have the OK HTTP client that Android will provide me. If I'm doing this on iOS, I'm going to use ios.create. When I receive this information, I want to update my UI. I can do this as I used to do on Android easily. Okay? I can still use my libraries. I don't have any limitation here. Glide in this case, what it does is I receive an URL, it will download the image and set the image on my image view, and I will apply a circle to that image just to be pretty here. If you look at the iOS code, it will be pretty similar, okay? This is done on Swift, and the difference here, it's how we define this, okay? On iOS, we have v will appear, and here we're going to call that attach view method, that once again is common to Android. And when we receive that update, we're going to reload our table view. This is exactly the same thing, but done on iOS. Conclusions. You have to keep in mind that Kotlin Multiplatform is still on its experimental state. You will face a couple of issues, and some of them are more tricky than the others. So when you decide to push your code entirely, or your entirely code base to Kotlin Multiplatform, you should start small, okay? Don't try to get 100% at the first time. You have a big problem here if you're an iOS developer. You cannot debug code on Xcode, okay? You need to go to IntelliJ and to debug your shared model there. You still need to look out for plugins and libraries update. If you make an update on a library, it's possible that the code stops to compile by some strange reason for now. Positive things. It has a really strong community, okay? A lot of people are already using Kotlin nowadays, and we start to have several companies, not only in Portugal, but in the entire world, doing Kotlin multi-platform. If you look at the Kotlin Conf that's going to be on December, we have a lot of talks already submitted of projects in production using it. Once again, it's 2 times faster to develop because you can share your business logic. And since you share the business logic, you'll also have your own tests that can be reused across platforms. And of course, it's one tech stack. You'll only have to care with this stack, okay? You don't need to care with separated stacks. All the issues will be solved in one. Once again, be extremely careful with updates. Keep versioning in mind. If you manage to have a feature working in a specific version, commit it, and don't try to update the whole thing when there is a new update. Start small, and remember that's still on experimental state. Some extra information here. If you want to start, you can DM me on Twitter, or you can just follow these links. This is the community nowadays. I strongly recommend you to go to Kotlin Slack or Android.Portugal Slack, because we're talking a lot of Kotlin there. So, thank you, and okay. If you have any question, please ask.
Thank you very much. All right. If any questions from the audience for Carlos? There's one question here in the front.
So my question is, how would you compare Kotlin multi-platform to what React Native is doing, and what are the advantages or disadvantages between the two of them?
Okay, React Native, it's pretty cool. You can use it with Kotlin multi-platform without any problem. You can do things in React and still use Kotlin. But the goal is different. When you want to do React Native and how you want to do, for instance, of Flutter, you want to do the entire thing and leave the compilation to the React Native itself. So we won't have a shared model. We'll have everything shared. Here, what you want to share is just the logic. So you don't want to face chain problems that we're going to have when using React Native. For instance, there was an iOS version that updated the entire UI. They decided to make a revamp, and I think we didn't have React Native at the time, but we had Xamarin. And when you were compiling those applications, if you were doing it natively, when it was running on the device, it automatically used the device components. So you could have that new feel. But since you're using views that were created to look alike the natives, when you try to use your application on this new version, it will have the old look. For me, this is the biggest problem. Of course, you still don't have, and this is really debatable because there is both sides. But you can't also have the same performance that you can achieve with native. And Kotlin gives you that support. You can still run things natively, but you have this model that is shared across all places. And you don't have that overhead, that runtime overhead that you have with React Native, with NativeScript, with Flutter, etc. So responsiveness, fastness are my major concerns.
Thanks.
There are any other questions? Who's going to be moving to Kotlin tomorrow? Well, maybe Tuesday, after San João. Everyone? No? Right, so thank you very much, Carlos. Thank you for coming.